Imagine balancing a 50-pound metal ladder on your shoulder, right? And you're suspended midway up the side of a burning multi-story building.
Just incredibly dangerous.
Exactly. Your heart is hammering, adrenaline is just completely flooding your system, and literally every instinct is screaming at you to move faster.
Yeah, get off the wall. Right.
Right. But then, right in the middle of this super precarious climb, you are forced to stop completely.
Yeah, just a dead stop.
Yes, a dead stop. You have to break your upward momentum, physically look down at the ground, and shout a notification. I mean, it sounds like a complete contradiction to the urgency of an emergency.
Or even a recipe for a disastrous fall.
Right. But today, we're going to explore why this highly counterintuitive pause and, dozens of other rigid maneuvers just like it are actually the secret to mastering chaos.
That's fascinating.
Welcome to the Deep Dive. We've built this exploration specifically for you to dive into the hidden structures behind complex, high-stakes performance.
And we've got some really great source material today.
We do. We are looking at the performance-oriented outline for the Florida Fire Minimum Standards Practical Exam.
Specifically, we're focusing on the ground ladders module. So the exact skill we are dissecting is the deployment of a roof ladder on a multi-story pitched roof.
Which sounds intense.
Oh, it is. It's a document that takes this brutally physical, inherently dangerous operation and it breaks it down into a highly formalized choreography.
So the mission of our deep dive today is to understand how human beings execute this massive physical challenge without letting panic take the wheel.
Because that's the real enemy, panic.
Exactly. We are talking about 17 distinct mandatory movements. And they're all governed by a ruthless, unforgiving time limit of exactly 4 minutes and 40 seconds.
And not a second more.
Right. Okay, let's unpack this. Because, long before a firefighter actually puts their hands on the aluminum, before a single muscle even strains to lift that ladder, there is an entire mental chessboard that has to be set up.
Yeah, the initial phase of this physical exam is actually entirely verbal, which surprises a lot of people.
It surprised me.
Right. The source text calls it the initial command level size up. A candidate, they cannot even adjust their footing toward the ladder until they've completed this massive verbalization.
They literally have to stand there and deliver this highly detailed operational brief.
Which is a lot to remember under pressure.
It's huge. You're confirming you have full PPE on. You're anticipating an IDLH environment.
That's the immediately dangerous to life or health environment.
Right. And stating you'll go on air if needed. Plus, you're formally notifying the incident commander, acknowledging the need for a charged backup hose line, confirming you'll shut down utilities.
Don't forget finding a second means of egress.
Oh, yeah, finding an escape route and verifying that you are going to operate on the windward side and uphill.
It's a massive checklist.
And then finally, you have to explicitly repeat the assignment. Quote, I acknowledge the order to deploy a roof ladder on a multi-story pitched roof. I mean, it's an incredibly dense amount of information to process out loud.
But it acts as an environmental anchor. Every item on that verbal list corresponds to a catastrophic variable that could, frankly, kill a crew if left unaddressed.
Okay, I hear that, but I have to push back on the application here a little bit.
Sure, go ahead.
Because, a pilot runs through a detailed pre-flight checklist, right? But they are sitting in a quiet, climate-controlled cockpit on a tarmac.
Usually, yes.
A firefighter is standing outside a blazing structure, or, at least simulating that exact high-stress pressure cooker for an examiner. Does standing around reciting an essay actually help when a building is coming apart?
That's a fair question.
Or is this just academic red tape bleeding into fieldwork? It just feels like precious seconds are ticking away while someone recites a speech.
Well, what's fascinating here is the neurobiology of stress and how this specific training counters it.
Okay, how so?
This verbalization isn't red tape at all. It is a forced cognitive override. When a human being faces a high-stakes, adrenaline-fueled scenario, the amygdala...
The threat center, right.
Exactly. The brain's threat center takes over. And the biological response to that is tunnel vision.
Wow, okay.
Your brain basically decides the only thing that matters is the immediate goal, which in this case is getting the ladder to the roof. So peripheral awareness completely vanishes.
You just stop seeing things.
You stop seeing the sagging power lines. You stop noticing the shifting wind direction.
So the brain is essentially trying to be too helpful by hyper-focusing, but in doing so, it actually blinds you to the broader environment.
Precisely. By forcing the firefighter to verbally articulate the wind direction, the escape routes, and the utility hazards, The exam demands that the prefrontal cortex,
The logical part.
right, the logical, analytical part of the brain stays actively engaged, because you cannot recite that complex checklist using just your fight or flight instincts.
That makes total sense.
It proves to the examiner, and honestly to the firefighter's own nervous system, that they are thinking dynamically, not just reacting blindly.
That reframes the whole concept for me. The speech is essentially a biological hack to keep the executive brain online.
Exactly.
And once that mental foundation is laid, the exam shifts to the physical environment. But looking at the source text, the physical movement is not just a test of brute strength.
No, not at all.
It is governed by intensely strict spatial orientation. It is practically applied geometry.
Because the physics of moving a heavy, awkward object require absolute precision. I mean, a 50-pound ladder acts as a massive lever if it gets out of alignment.
Which you don't want.
No.
So you start with another verbal safety check, stating the main ground ladder is safe and heeled to the building. Then you initiate the transport.
With a very specific carry.
Yeah, you execute a low shoulder carry with the roof ladder, keeping the butt end forward. And as you walk, you have to verbally announce that you have no overhead obstructions and your terrain is clear.
Always vocalizing the environment.
Right. And then you arrive at the main extension ladder, and the positioning is incredibly specific. You place the butt end of the roof ladder perfectly in between the heels of the ground ladder.
Dead center.
But here's where it gets really interesting. Preparing the hooks.
Ah, yes. The hooks.
So these roof ladders have large spring-loaded hooks at the tip that, grab the peak of the pitched roof.
Right.
The manual explicitly mandates that you must open the hooks and ensure they are facing outward, away from your body.
Very important detail.
And then you bend your knees, raise the ladder, and hook it to a rung on the main ladder. But why such an intense, almost obsessive emphasis on the hooks facing outward before the ladder is even off the ground?
Okay, think about the physical profile of a firefighter, fully geared up.
Right, they're huge.
They are wearing bulky, fire-resistant turnout coats. They have a heavy SCBA air cylinder strapped to their back with, various loops, regulator hoses, maybe a thermal imaging camera hanging off their chest.
So much gear to snag.
Exactly. And a roof ladder hook is essentially a large, jagged piece of metal designed to bite into wood and asphalt.
Oh, I see where this is going.
If those hooks are facing inward toward the firefighter's chest or shoulder during that chaotic heavy lift, the probability of them snagging on that gear is astronomical.
So catching a strap while you are hoisting 50 pounds sounds like a quick way to tear your gear.
It is much worse than just tearing gear. If an inward-facing hook catches a heavy shoulder strap midway through a lift, that hook becomes a fulcrum.
Oh, wow.
Yeah. The weight of the ladder acts as a lever arm. As the ladder shifts, it will violently peel the firefighter off balance.
That's terrifying.
If they are already on the main ladder when that happens, they're getting pulled straight off the rungs and falling backward.
Oh my God.
So forcing the habit of outward-facing hooks while still safely on the ground neutralizes that deadly leverage.
It transforms a massive safety hazard back into a simple, predictable tool, risk mitigation at the ground level. Which brings us to the climb itself. The roof ladder is prepped and hooked onto the extension ladder. Now you have to haul it up the side of a multi-story structure. The mechanics of this mid-air choreography are wild to visualize.
Because climbing a ladder is straightforward. But climbing a ladder while transporting a second ladder,
Not so much.
it introduces an entirely asymmetrical center of gravity.
So you begin the ascent using a standard rung grip, climbing until your shoulder aligns exactly with the 2/3 mark of the roof ladder. The document clarifies this is 1/3 from the tips.
You have to hit that exact center of balance.
But then comes the mandatory stop we talked about earlier. Midway up the side of the building, the manual requires you to stop, break your upward gaze, look down at the ground, and yell, quote, "I am notifying exterior crew."
And the physical act of looking down is heavily scrutinized by the examiner.
Wait, really?
Oh, yeah. You cannot just shout it into the side of the building. You have to direct your attention downward.
Okay, this is where the logic feels completely broken to me. You are suspended halfway up an extension ladder. You are moments away from balancing a second heavy ladder on your shoulder.
Right.
Why introduce a dead stop? Looking down and yelling at an exterior crew seems entirely counterintuitive to the goal of moving quickly and efficiently.
It seems like a waste of time.
Yeah. Why wouldn't you just notify the ground crew before you even started climbing? Why wait until you are in the most precarious position possible?
Well, if we connect this to the bigger picture of a dynamic fireground operation, The timing is actually perfect.
Okay, lay it on me.
Consider the environment. Fire scenes are chaotic, they're incredibly loud, and conditions evolve by the second. If you notify the ground crew before you start your initial climb, 3 or 4 minutes might pass before you reach the transition point where you actually lift the roof ladder onto your shoulder.
And a lot can happen on the ground in 4 minutes.
Exactly. In that window, an exterior crew member, a medic, or an incident commander might have walked directly underneath your ladder, completely unaware that a heavy piece of aluminum is about to become a mobile overhead hazard.
Oh, I hadn't thought of that.
By forcing the notification at the precise moment the overhead danger is activated, you eliminate the gap where friendly fire accidents happen.
It's real-time accountability. You aren't warning them that you might drop something eventually. You are warning them that the hazard is live right now.
Exactly right.
So after that notification, you execute the transition, you thread your arm through the rungs of the roof ladder, rest it on your shoulder, and the manual reminds us once again, hooks still facing outward.
Always outward.
Then you ascend the main ladder while maintaining 3 points of contact, sliding your free hand along the beams.
And maintaining 3 points of contact, meaning 2 feet in one hand or 2 hands and 1 foot securely on the ladder at all times, is incredibly difficult when your torso is heavily weighted on one side.
It sounds like it requires a ton of core strength.
It does. Yeah. It requires a tremendous amount of core strength and deliberate footing to prevent the ladder from inducing a lateral swing.
And reaching the roof line feels like it should be the finish line, you know? You've made the climb. But reading through the outline, arriving at the roof is clearly just the start of the most dangerous phase.
Because you are transitioning from a vertical ascent to deploying equipment onto an angled plane.
Yeah. The roof line introduces a completely different geometric puzzle. The firefighter has to secure a work area on a slanted, potentially slippery surface while suspended high in the air.
And usually while dealing with smoke and heat.
Unbelievable. The manual says you stop at the designated working height, and it explicitly warns, do not rush transition. Next, you have to execute a leg lock on the opposite side of the work area unless you are using a rated harness.
Right, tying yourself in.
Only after you are fully locked in do you take the roof ladder off your shoulder, place it flat onto the pitched roof, and slide it upward toward the peak.
And the mechanics of sliding the ladder flat along its beams are crucial here. If you try to carry it or lift it over the roof, the wind catches it, or the weight shifts. Pushing it flat distributes the load across the shingles.
And then comes the hook engagement. Once the hooks clear the peak of the roof, you lay the ladder flat so the hooks point downward, and you pull back firmly until they catch over the ridge.
That's the anchor point.
So what does this all mean? When I visualize this entire sequence, it's like trying to accurately throw and anchor a heavy grappling hook onto a castle wall.
That's a great visual.
But before you can even attempt the throw, you have to literally tie your own leg into a knot around the ladder you're standing on just to free up your hands.
Yeah, the grappling hook analogy hits the nail on the head regarding the sheer awkwardness of the task. The leg lock is essentially the firefighter deploying their own outriggers.
Outriggers, like on a truck.
Think of a heavy construction crane. If a crane extends its boom without deploying the wide outriggers on the ground, the leverage will tip the entire machine over.
Ah, so the boom extending is the firefighter pushing the ladder up the roof.
Yes. When the firefighter weaves their leg through the rungs and hooks their boot back around the beam, they fundamentally change their center of gravity.
They anchor themselves.
They anchor their lower body to the vertical plane. It turns their torso into a stable, secure boom that can twist, push, and pull a heavy object without the risk of their body weight shifting backward into open air.
Man, it is brilliant biomechanics, but it sounds absolutely exhausting.
It really is.
So you finally get the hook set, the roof ladder is secure, and then we hit the neutral position.
The final step.
You remove the leg lock, you place your feet securely back on the rungs, you wait exactly 1 to 3 seconds, you state out loud, quote, "I am at the neutral position," and only then do you begin your descent.
Such a crucial pause.
But why mandate a specific 1 to 3 second pause? It feels incredibly cinematic, like taking a breath after defusing a bomb.
Well, that pause acts as a biological brake pad. Think about the physiological state of the firefighter in that exact moment. They have just hauled a heavy ladder up a vertical plane, balanced it, executed a complex leg lock, pushed the weight up an angled roof, and yanked it back to secure it. Their heart rate is likely maxed out. Their muscles are flooded with lactic acid.
They're probably shaking.
Exactly.
Yeah.
And momentum has been driving them forward and upward this entire time.
So if they immediately transition into climbing backward down the ladder, all that lingering momentum is going the wrong direction.
Exactly. Rushing the descent while still running on peak adrenaline is when boots miss rums.
And falls happen.
Yes. That 1 to 3 second pause forces the inner ear fluid to settle after looking up and twisting.
Wow, I didn't even think about the inner ear.
Yeah. It allows the brain's motor cortex to process the somatic feedback that their hands are now empty. It proves to the examiner and the firefighter that they are in total control of their body mass before they introduce gravity back into the equation.
A forced reset for downward precision. So you descend, maintaining those 3 points of contact until you reach the ground, confirm stable footing, and await further instructions.
That's it.
That is the 17-step physical ballet. But hanging over every single one of these intricate movements is the ultimate crucible of the exam, the ticking clock.
The element that separates theoretical knowledge from practical mastery.
The source material is brutally clear on time management. You have an absolute maximum time limit of 4 minutes and 40 seconds.
It goes by in a flash.
And they don't just give you a blanket countdown. They provide an exact time allowance for every microphase. You get 30 to 45 seconds for that complex initial size up.
Right.
60 to 90 seconds for ladder placement and the raise, 60 to 90 seconds for the entire climb, another 60 to 90 seconds for the peak roof deployment and the hook set, and 30 to 45 seconds to safely descend.
It leaves absolutely zero margin for error. Every single second is accounted for by the examiner's stopwatch.
But the document highlights a, quote, critical factor at the very bottom: smooth transitions between steps without hesitation.
That's the key.
But with only 60 to 90 seconds to execute the most dangerous part, the actual roof deployment. How does a human being avoid panicking? If I know I only have a minute left to tie my leg into a structural anchor, slide a metal ladder up a slanted roof, and secure it, the psychological pressure would force me to rush every movement.
And this raises an important question about how we perceive speed in high-consequence environments.
What do you mean?
The paradox of speed is that rushing actually destroys efficiency. When an untrained person tries to move fast, they rely on frantic, jerky muscle movements. They drop things, they fumble.
They miss the leg lock and have to redo it, which burns, 10 seconds?
Precisely. The source text explicitly instructs the examiner not to reward frantic speed. The mandate is smooth transitions without hesitation.
Smooth is fast.
Exactly. Hesitation is a cognitive delay. It means your brain is struggling to recall the next step. Frantic rushing is a motor control failure. By practicing the choreography until the cognitive overhead is near zero, the firefighter's movements become deliberate.
And smoothness eliminates the micro errors that waste time.
Exactly.
Yeah.
Deliberate action is the only way to beat a 4 minute and 40 second clock.
So what looks like raw, improvised heroism to a bystander watching a fire response from the street is actually a deeply ingrained, heavily scripted 17-step operational ballet.
It really is.
Every verbal command, every angle of a jagged metal hook, every single second of momentum is mapped out to conquer the chaos.
It is a masterclass in using rigid structure to protect human fallibility under extreme duress.
It truly is. Now, as we wrap up, the source material notes that this outline can be utilized as a memorization script, literally a word-for-word exam speech or a rapid-fire checklist for last-minute drill prep.
Which is very practical for passing the test.
Right. And that leads to a really profound final thought for you to ponder as you go about your day.
Yeah, because the material perfectly scripts the ideal response for a sterile test environment. But consider what happens to a firefighter's mental processing when a real-world multi-story roof suddenly presents an unpredictable variable.
Like something not on the checklist?
Right. What if a section of the roof has collapsed, or a civilian is trapped on a balcony that isn't in the script? If a professional's brain relies entirely on reciting this rigid, perfectly timed 17-step routine to function under pressure, does that deep psychological ingraining save them when the environment goes completely off script?
Or does the script itself become a trap?
Exactly.
It is the ultimate tension between standardization and adaptability. We uncovered a world built on absolute rigid rules to survive the flames. But perhaps the true test of mastery isn't just knowing the script flawlessly, but possessing the cognitive flexibility to know exactly when the script has to be rewritten on the fly.
Something to think about.
We'll leave you to chew on that. Thanks for joining us on this deep dive.